You've almost definitely used something powered by a microcontroller today. Your phone, it has several. Your microwave, your car key fob. But what are microcontrollers, and how can you incorporate them into your project? Hi, I'm Bipul Krishna. I've been doing competitive robotics for 4 years, and I've worked on everything from RC cars to FOC robots. In this video, I'll explain nearly everything you need to know to get started, whether you're building robots, smart gadgets, or just want to understand how stuff works. So, if you're a beginner, you might be wondering how a machine turns into a robot. How do you breathe life into a mechanism or contraption? You might already know that sensors collect info, but where does that info go to be used and processed? That place is a microprocessor. In a way, you can think of it like a control hub. Information comes in, stored as variables. Your code uses those variables, and then your machine follows the instructions your code generates in response to that to move and produce the desired result. That's basically what a robot is. A microcontroller is basically just a small computer. Literally, it's got a processor, memory, and input and output. It's on one tiny chip. It runs programs that you write, and usually they control specific tasks: turning motors, reading sensors, blinking lights. But why complete processing on an onboard computer? Like, couldn't you just have all processing more powerful than a PC? In robotics, there are various reasons like latency or mobility. Like, imagine bringing a PC on a homemade drone just to control it. It would be laggy. That's latency. The key difference from a regular computer is that microcontrollers are specialized and real-time. They're built to react to their world quickly and consistently. But aside from mobile robotics, they're often just the simplest, cheapest, and most reliable solution. Let's say you want to build an automatic plant watering system. Your microcontroller reads moisture levels from a soil sensor, checks its data, and it activates a small water pump. That's it. No screen, no keyboard, just sensing and doing. You'd use a microcontroller over something like a Raspberry Pi because you don't need a full operating system or a complex interface. You just need a fast, reliable control. Oh, by the way, Raspberry Pi is a microprocessor, specifically a microprocessor-based computer. It's a single-board computer, SBC, containing a microprocessor that can run a full operating system in Linux. The Raspberry Pi Pico is a microcontroller. If you're interested, I'll drop a video on microprocessors soon, but microprocessors are just typically more powerful. There are dozens of microcontrollers out there. Let's focus on a few popular ones you're likely to use. The Arduino Uno. The Arduino Uno is the beginner's classic. It's big, friendly, and simple to program. It uses an ATmega32 8P chip and is perfect for learning and prototyping. Downside, it's large and lacks wireless features. So maybe something like a simple robotic arm would be really easy to use with this chip. The Arduino Nano. The Arduino Nano is basically a think they're cheaper too. It's the same chip, so the same capabilities, but it's a lot smaller and fits into a breadboard. If space matters, you should use the Nano. So, what about more mobile products or products that need to communicate to other devices? The ESP32 type is small, powerful, and includes built-in Wi-Fi and Bluetooth. It's perfect for smart devices, wireless sensors, and other projects. You can do way more with it, like send data into the cloud, control it from your phone, or stream sensor data over Wi-Fi. If you do have a project that needs to connect to a computer, you could do that with the ESP32. How do you implement it in a build? Like, what do you need for it? Okay, here's what you need to actually use a microcontroller in a project. So let's say you're building like a robotic system, right? So step one, you get it, and you connect it to your computer, usually via USB. With a Raspberry Pi Pico, it's USB-A. And step two is write your code using an IDE like Arduino IDE or Platform.io, VS Code, PyCharm, and Thonny is for Raspberry Picos. I have experience in that. Some coding knowledge may be needed. Usually Python is the only language you need to know for basic. And step three is you upload the code. The controller should store and run it immediately. And then you can do tests if you want to like confirm this is working. Like, make a function to light up an LED and then do that before you actually use it. And then step 4, you just connect your hardware to it. You like motors, sensors, LEDs, whatever. Usually with physical cables to and from the printer. From here, your microcontroller becomes the brains of your build. And now finally, let's just talk about some scenarios you would use some sensors. Microcontrollers talk to real world through sensors and outputs. Here are a few useful ones that you might come across, and they're commonly used in the field. And it's just nice to know these too for any projects. So of course you probably know motors and servos. These let your project move or interact with the world. This is typically what you'll be using microcontrollers for. Motors are a lot more powerful and they use a lot more voltage than servos. Servos are a lot lighter. And potentiometers. So these measure rotation or resistance. Like think volume knobs, like the ones that you twist. This is useful as an input and using that data as a variable in code, like an integer variable, for example. And then accelerometers. So these are useful in mobile projects. These detect motion and orientation. So ultrasonic sensors. They detect distance, like echolocation. I really doubt the sensor could be that useful in a day-to-day project, but it has its uses. Oh, but laser sensors are useful, especially for AI motion. You will use these more typically. And in FRC or FTC, we have QR scanners, so cameras, which also can be added. And then temperature sensors. They're self-explanatory and super common. You can mix and match these with your microcontroller depending on what you want to make a self-balanced robot. You can use an accelerometer or a drone. If you want a smart lamp, you can use a light sensor. Alright, this is Bipul Krishna, and this was some real honest advice. I hope this video helped you. Thank you for watching the video. I wish you good luck on your projects.